Different types of capacitors. Capacitor types. Capacitors are essential components in electronic circuits, playing a crucial role in storing electrical energy. They are categorized into various types based on their construction and dielectric properties. 1. Dielectric capacitors. Dielectric capacitors are a broad category encompassing capacitors with various dielectric materials. These materials determine the capacitor's properties like capacitance, voltage rating, and temperature stability. 2. Film capacitors. Film capacitors are widely used due to their excellent performance and reliability. They consist of a thin film dielectric sandwiched between two conductive layers. Common film materials include polyester, polypropylene, and polystyrene. 3. Polycarbonate capacitors. Polycarbonate capacitors utilize polycarbonate as their dielectric material. They offer a good balance of capacitance, voltage rating, and temperature stability, making them suitable for various applications. 4. Silver mica capacitors. Silver mica capacitors are known for their high stability and precision. They employ mica as the dielectric and have a thin layer of silver deposited on it. These capacitors are often used in high-frequency circuits and precision applications. 5. Electrolytic capacitors. Electrolytic capacitors are characterized by their high capacitance values. They typically consist of a metal foil anode covered with an oxide layer that acts as the dielectric. These capacitors are polarized, meaning they must be connected in the correct polarity to avoid damage. 6. Aluminum electrolytic capacitors. Aluminum electrolytic capacitors are the most common type of electrolytic capacitor. They use an aluminum foil anode with an aluminum oxide layer as the dielectric. The space between the foils is filled with an electrolyte solution, which is absorbed into a separator material. 7. Tantalum electrolytic capacitors. Tantalum electrolytic capacitors offer higher capacitance values and better stability than aluminum electrolytic capacitors. They use tantalum as the anode material and tantalum pentoxide as the dielectric. 8. Supercapacitors. Supercapacitors, also known as ultracapacitors, are a relatively new type of capacitor with extremely high capacitance values. They are constructed using activated carbon electrodes separated by a thin electrolyte separator. Supercapacitors can store significantly more energy than conventional capacitors and are used in applications requiring high power bursts, such as energy recovery systems and backup power supplies. Conclusion. The choice of capacitor type depends on the specific requirements of the application, including capacitance value, voltage rating, frequency range, temperature stability, and cost. Understanding the characteristics of different capacitor types is crucial for selecting the appropriate component for any given electronic circuit.